All right, so we're going to look at reviewing the Algebra 1, Algebra 2 graphs that we should know. We already looked a little bit at lines. We're going to look at parabolas and see what we know. So first, in one of our previous videos, we wrote these 3 different forms for quadratics. So standard form, we know a couple things from standard form. We have standard form here. So one thing you should have thought of is that we can figure out the vertex, or at least the x value of the vertex, and then we can plug that back in. So the x value of the vertex we can figure out, and we remember that's from negative b over 2a. Right? So from plugging that in, we can figure out our x value. Then we can also figure out our y-intercept. We know that because it's going to equal just c. And then we can also figure out if it opens up or down based on the sign of the leading coefficient. And the leading coefficient is a. So that's our first one. I want you to think for a moment, what can you find again from vertex form? From vertex form, you can find the vertex, right? So the vertex, in this case, we would write it x minus h squared plus k. And we're going to write it as minus h every time, because then our vertex, we know, is hk. And we're going to see this not just in quadratics, but in all sorts of other graphs as well. Another thing, we could still figure out if it opens up or down, and looking at the sign of the leading coefficient, which is a. The last one is our factored form. And factored form gives us right away our roots or our zeros, and we could write those either as x equals our p-value and x equals q, or we could write those as ordered pairs, right? And then we can also tell by our sign of our leading coefficient if this opens up or down. So here are the things we should remember from these different forms. Now we're going to practice them. I'm going to go back and forth between drawing them and then also explaining. And you should be able to sketch each of these graphs on your paper. So here's the first one. Remember as we have this, we have our y equals mx plus b form. So we're given our slope and we're given our y-intercept. So for this one, we know our y-intercept is at -1. We know our slope is 3, which means up 3 over 1. So we can put a point at -1, and then we go up 1, 2, 3 over 1, up 1, 2, 3 over 1. And we can also go -3 over -1, right? A negative divided by a negative is a positive. So then we still get that 3 over 1 that we had up here. So we could go down 1, 2, 3 into the left one, and then we can connect this and make our line. Right? So you could sketch that line on your graph also based on this graph, right? So we know our y-intercept, we know our slope based on that equation. And we get this line here. All right, the next one, we're going to graph y equals -x over 2. So this one, notice how there's not a plus b. So that means that we start, and our first point is actually at the origin. So I'm going to make this a little bolder for you so you can see it. Our first point's 0, 0, and then -1/2 is our slope. So remember, we want it to look negative, so it's going to go in this direction here. So we're going to go down 1 over 2, right? Our slope rise over 1, down 1 over 2, down 1 over 2. And this should hopefully be review to you. I'm doing this on the computer, so it might be, might not be as exact as if I were to write it, but you can add this graph also with your -1/2 slope, and then connect that for your line. The next one, I want us to think about y equals x squared. So y equals x squared, this will give us a parabola, we know that. This is our parent function of a parabola, of a quadratic. And let's look at the table of this. So I'm going to plug in values for our table. Remember, for our table, we always want to start with like -2, -1, 0, 1, 2. We want to kind of go on both sides of the axis to see what it looks like. So make this table with me. Now remember, when I have -2 and I'm going to square that whole thing, I'm going to do -2 times -2, which will give me +4. -1 squared will give me 1, 0 squared, and then so on. And if I sketch a graph of this, I'll notice that there's a little pattern to it. And what I noticed also, and what you should have noticed from Algebra 2, is that if your leading coefficient is 1, then you kind of see this pattern of up 1 over 1, up 3 over 1, and then it would be up 5 over 1. So you see that pattern continue. And let's just do one more. So if we had y equals x squared plus 1, notice how our leading coefficient is still 1. So we could plug in the same x values for our graph to figure out what it looks like. So let's try it. So over this one, -2 squared, we get 4. 4 plus 1 is 5. So we plug 5 in. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. So I'm going to plug those in. And then what happens to my graph? Well, we know that this also tells us our y-intercept. So what we're doing with this graph, if I sketch it real quick, is I took our parent function here and I just shifted it up 1, right? So I moved every single point up 1. So notice how our leading coefficient was 1. So therefore, we still followed the same pattern. So we went up 1 over 1, up 3 over 1. We could also go up 5 over 1, and then we have symmetry on both sides here, right? So really noting that pattern when your leading coefficient is 1, that it's going to be the same, and how that helps us. So we're going to graph a couple more functions using these different forms of quadratics. So here's our first one. So this one is in standard form. So things I think of right away, I can find the vertex of this. And I also could factor it, and I know my y-intercept right off the bat. So let's first find our vertex. Okay, so vertex, remember, was -b over 2a. Remember that the a, it's really like ax squared plus bx plus c. So using those values, we'll plug that in. So we got opposite of b, because it was negative, so it turns +2 over 2 times 1, which is 1, right? Because we got 2 over 2. Those are the same, so we get 1. So that's our x value. And then we can plug that in to figure out our y value. So I'm going to show that work also. So I have my vertex at 1, negative 4. I plugged in 1 here, so 1 squared minus 2 times 1 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3, I get negative 4. So I get this point, this ordered pair, as my vertex, right? Then I know my y-intercept because if x is 0, so 0 squared plus 2 times 0, which would be 0, minus 3, then those first two would become 0. Minus 3, I get negative 3. So for my y-intercept, I get the point 0, negative 3. I notice my leading coefficient is 1. So I do start to see this pattern here, but I can also figure out my, my zeros from factoring. So I'm going to create a little more space here. You have a page, so you already have the space, hopefully. And let's factor this also. So we can use RS. Remember for RS that if our leading coefficient is 1, we also notice a pattern there as well. So we're trying to figure out what multiplies to give us negative 3, adds to give us negative 2. And we've written this a couple different ways. Right, those are two different ways that we've seen this. So we're thinking what multiplies, what adds. Multiplies to give me 3 would be 3 and 1. And then if 3 was negative and 1 was positive, that would add to give me negative 2. Good. So then what I think about is, all right, so I can do factoring by grouping. Sorry, keep coughing here, Anya. So here we take our original function, we're factoring by grouping. So we have our left side, we have our right side that we take. We split up this middle term into our two factors, the r and the s that we found. And we ended up with x plus 1 and x minus 3. But what you notice here is when our leading coefficient is 1, then what we see is that the factors that we end up with are really the r and the s values that we had. So we got these values, the negative 3 and the 1, because our leading coefficient was 1, then those were also the values that went right into our factored form. Okay, so R and S, that was just a brief little review of that. And we figured out what our zeros are, and we can keep solving these. I'm going to just shrink this a little bit so we can look at the whole graph. And what you notice, remember we'll set this back equal to 0. We solved for both of the x's, so we got our zeros at negative 1 and 3. And notice on this left side here, we found this pattern of up 1 over 1, up 3 over 1. So we have to make that mirror on the other side, right? So there should also be a point right where my cursor is here. So we're going to add that in. And then we have our parabola, okay? So this is from just standard form, how we can figure out our graph. If we look at vertex form, so this one is in vertex form. One thing we know about this one is our vertex is at the opposite of H, and then whatever the k is. So our vertex would be at -2, 1, right? So -2 and then up 1. And then it's negative, and our leading coefficient here is -1. So this one, because our leading coefficient is -1, it's going to go down, but it's going to follow that same pattern. So we can do our regular pattern here. And then there's other, so this is a y-intercept. This should really be moved over just a titch over here. Good. And then one way that we could check this is we can factor this out. So I'm going to show us factoring it on the side here, and then we can see how they connect, how the standard form connects with this. So far, I just FOILed this out because I remember x plus 2 squared. I'm going to write it twice and FOIL it, combine it. Next, and I have to multiply this negative first before I can do the adding. So I'm going to multiply that through. And then I'm going to combine my like terms. And that is equal to what I had at the top here. Now, one thing that we notice is we have -3 as our y-intercept. 1, 2, 3. That one matches up. We could also factor this and find these two values, but we just practiced RS method, so we're going to go on to our next one. And here's our last one. So we have this in factored form. So our factored form, we already know what our zeros are now, so we'll set this equal to 0. So we found our zeros at 3 and at -1. Now this one, we could also factor it out, and we could find our y-intercept, and then because our leading coefficient is 1, because all the x's both have 1, and then out front there's a 1, then we could see the pattern here. So let's FOIL this one out also. So we FOILed that out, we combined our like terms, and we see that our y-intercept would be -3. So you notice that from these 2 points that we go down 3. So we're probably going to go down 1 over 1, up 1 over 1, up 3 over 1 to complete the pattern. So this one, we can see from our pattern, we can see from our zeros, and we've got all these different graphs that we've looked at. And notice here how this graph, x squared minus 2x minus 3, this one is just in factored form, right? So we found that before, but we can go back to standard form to find more aspects about this, right? We could also find our vertex from our standard form. So I know this was a little longer, but It goes through a lot of those details that you looked at before. And I will see you all later. Thanks. Bye.